Hello, this is Enrique Herrera, your professor. I'm here, as many students requested, solving the dynamic programming algorithm on your homework. That was question 3 or your homework 1. And I apologize a little bit for the prop. It's not that clean, but it's, I think, functional and it serves our purposes. Basically, in here, we're going to do the dynamic programming algorithm. So to do that, you place one sequence on the columns and one sequence on the rows. At the same time, you have to add one row for a gap and one column for gap, right? This one doesn't, it's just gap. So the first entry is 0. Why? Because this is gap and gap. Now, when you set up, all matrices started like this, right? Because this is just the gaps. Now that you have it started, once you have this like this, you have to initialize the matrix, meaning you have to make these entries. Why are these entries all -2, -4? Why is that? Well, because if this entry is 0 and I move in this direction, that means that was a gap. And when I went from here to here, the scoring matrix says that gaps are -2. And your example is said the scoring matrix was match 3, score 3, mismatch -3, and gap -2. So that will be the -2. If I continue moving in this direction, this G will be gap -4, A will be gap -6, G will be gap -8, and so on. Same for the columns. This will be gap -2. If I continue here, gap -4, so on and so forth. Okay? So now that we have that taken care of, this is considered an initialized matrix. You also have to understand that the complexity for this algorithm is n to the cube. And why is that? There is a proof to prove formally why that is, but intuitively it's actually quite straightforward to follow. Clearly there are 2 dimensions. You have to go across the rows and you have to go across the columns. That has to be n squared. But in this algorithm, even when you're done filling out the matrix, you're still not done. You have more operations to go. That means that you have to, the upper limit is n cubed. So that's why it's n squared. If you have a hard time following what I mean by big O notation or complexity, then you need to review those, because that's going to be important to evaluate algorithms, okay? So in this case, once we want to, the formula says that you have to pick from -I1 and -J1 in the rows above and below. And to do that, you say, what is the maximum of these 3 cells? The maximum is 0. So if you go 0 and you go into the diagonal, this will be A. A is a match. The scoring matrix says match is 3. So 0 plus 3 is 3. So now you have filled that column. But now let's say that you want to move to the next one below. And then you look at it and you say, what is the maximum of this 3? The maximum of this 3 is 3, right? But if you move into this direction from that maximum, that will mean that will be gap. So 3 minus 2 is 1, right? Let's go into this one. From this 3, this will be, what's the maximum? 3. But if you move into that direction, that's a gap. So 3 minus 2 is 1. Let's go into this one. What's the maximum? 3. G. G is a match. 3 in the diagonal for the match. 3 is 6, right? Let's do this one. Maximum, the maximum is 1, but if I move below, that's a gap. So 1 minus 2 is -1, right? And so on and so forth. Right? I'll do one more. This one, what's the maximum? 6. 6, but if I go below, that will be a gap. 6 minus 2 is 4. Okay? So,